Hello everybody, good afternoon. This is Deepak Sharma and I am host for today's half an hour session. I'm here to answer all your queries related to data science and give you an overview of how data science works. I'll take all the questions in the end. Right now, I'm going to launch a presentation which cover almost all aspects of data science. I hope I'm audible to all. Advisor team, can I start? Thank you. So friends, the purpose of today's call is to introduce you with data science. I hope that everybody is new here in data science and you must be having a number of queries before entering into this field. So my purpose here to answer most of your queries and give you a good hand holding into how to enter into data science field. So the topics that I'm going to cover is like what is data science, which is a question that comes in everybody's mind. And you must have heard about artificial intelligence. So what is artificial intelligence? And what is machine learning? And what is deep learning? So these are all the important things that goes in our mind. The various roles that we have in data science, because generally what happen when we apply for a job or when we apply for a particular role, a clarity should be very much required that exactly what will be expected from me in that particular role and the type of use case that are sold in data science. When I say use case, that means I'm covering almost all the industry use cases, and you will get to know that you might have been encountering all these use cases in day-to-day life, and you will surprise to see that they are going to happen because of the data science. And in the last, I'll address the most important part that what companies are looking for in the candidates when they apply for a data science role. And in the end, I'll take the questions. So first thing first, what is data science? So you must have heard about science in your school time. And when you say science, then there is always a reason behind any change. There's always a logic behind any change. And when we talk about data science, then we are exactly referring the same uh, vertical of data science where we look for a cause. We look for a cause for the behavior of the data. Now, there's the science that try to understand the logic behind the behavior of the data because ultimately we need to understand why my data is behaving like this and what is the reason behind what is causing this behavior and what logic can be in the form of mathematics formula or equations. So ultimately we try some mathematic equations which actually help us to explain the underlying reason why my data is behaving like this. Then ultimately we have to take out the hidden insight on the surface because when this applications works, when this example works, when the equations works, they bring out some hidden pattern, some hidden relationships which we cannot see just by seeing the data. So ultimately our objective is to bring that hidden insight on the surface because that hidden insight is going to help our management or our client to take a decision. So in a nutshell, I would say data science is looking for all the cause which is impacting a data to behave in a certain way and ultimately helping the management to take quick informed decision supported by data. Why it is informed? Because it is supported by data. Now the next part comes in what is artificial intelligence. When machines start thinking and take decision like humans, this is what we call artificial intelligence. It is a very broad term, but very like an apt for the definition of artificial intelligence because we are expecting our machines to behave like human. We are expecting our machines to answer like human, to take decisions like human, to think like human. And for that purpose, we have to train our machines. And the machine get trained with the help of this artificial intelligence vertical. Now, what we are going to achieve in the artificial intelligence, we can achieve AI with the help of machine learning. So most of people will say that, okay, can I achieve machine learning and AI together? See, AI is a concept which is there in 1950s onwards. So it is not a new concept, first of all. Therefore, in the past also, AI was there. Today, the way of doing AI, the way of achieving AI is different now. And that's why it is now a very, very big buzzword in industry. Today, we can achieve AI with the help of machine learning, with the help of deep learning, natural language processing, reinforcement learning, robotics, and rule based. These are the six main ways through which you can achieve AI in today's world, and how this each and individual vertical works, I will tell you in the next subsequent slides. So we talk about machine learning. It deals with system or algorithms. So when we talk about machine learning, we are expecting machine to learn something, and machine understand only numbers. Machine understand only algorithms. So machine learning vertical deals with systems or algorithms to learn relationship between your input and output. So what we are giving as an input. So a machine is something which takes something as an input and process it and give an output. So the underlying purpose of machine is not changed here. We still need some raw material as an input, and in our case, the raw material is the data. Now we are expecting some output from the machine, and that output could be anything, any decision that you wanted to make. So ultimately, it deals with system and algorithms and set up a relationship between our input and output and identify the hidden patterns. Always remember, if there is no pattern, then machine learning cannot be successful. Although the pattern can be hidden, but if there is no pattern at all, then machine learning is not going to help us. So the second comes the deep learning, which is a subset of machine learning. It's a special branch of machine learning where machine learns relationship again between input and the output. Input is our raw material, that is data, and the output is our decision using process used by human brain. So now we have entered one step in deep. When we say one step in deep, that means now we are expecting machine to think like human brains. Earlier, we were setting up some mathematical formulas, and that was helping our machine to take decision. But now, we are expecting it to behave like human brain. And when we talk about human brain, then there are many neurons, then there are many cells which actually work together, and then our human brain gives some output. The same thing goes with deep learning. Third is natural language processing. When I say natural language processing, that means it's a branch that deals with understanding of the human language. Whatever I'm speaking right now is a human language. Whatever you converse among your friends and family is a human language. Now, a branch of machine learning, a branch of analytics, which actually understand the human language and then take some decision. For example, it understands the sentiments, underlying sentiments. It also check like what is the question of the person, what kind of response I should give. You must have heard about chatbots, voice bots. These all are the application of natural language processing. Then come the reinforcement learning, again a special branch of machine learning where we do not have the target variables. When we say target variable, we do not know that what we are going to achieve with the help of our data. We do not have any label of the data. We do not have any output of the data, but we are completely on the experimental phase. When we are on the experimental phase, that means we give some rewards to our machine if it reach from destination A to destination B, and if it doesn't able to go there, then we penalize it. So it is more on reward and penalizing, and then machine automatically understand what is the best path for me, what is the optimal path for me to reach from one stage to another. This is what you call reinforcement learning. It is exactly same as like some robot is on some other planet. So this planet is completely new for the robot, and the robot doesn't know that whether the obstacle when it is walking is a stone, it's a big stone, is a small stone, should it change the direction, should it go back. So these all decisions are taken by the machines, and the moment a robot get an obstacle of a stone, it is penalized because it has choose the wrong path. Then it change the path and then it reward itself. Now come the robotics. You must have heard about the movie called Transformers, and this Transformer is exactly replica of what robotics is I'm talking here. So purpose is same. We are expecting machine to behave like human, but to see like human. So it look like human as well. It is not only behaving like human, but it is looking like human as well. It has an eye, it has an ear, it has an hand, leg, but ultimately some processor is going in the background. So these are called robots. Then come the rule based. As said in the starting, that machine learning is a new concept, but AI was there in 1950s. At that time, AI was able to take decision with the help of if this then this approach. Like if condition A happens, then what should be the output? If condition B happens, what should be the output? For example, if I'm swapping my card and I've given my passcode, if I given my PIN code, then if the PIN code match, then the transaction will be successful. So there are many ifs and else condition, and through those rules, machine were able to take decisions. So this is the rule-based approach. So this is the snapshot of all the algorithms which are available in the machine learning area, and these all algorithms are actually valid. These all are actually used in the industries. Now it is very difficult to learn all the algos at the same time. Ultimately what we have to do, we have to choose our path. What kind of opportunities I am getting? For example, if I'm getting an opportunity to work into deep learning, then we have special deep learning algorithms. If I'm getting an opportunity to work under regression area or the machine learning area, or maybe dimensional reduction, decision trees, Bayesian. So for every vertical, we have some set of algorithms, but ultimately all these are coming from machine learning algos. So machine learning algo is a base, then we can choose our specialization path. These all are actually running algorithms in the industry. So I wanted to give a snapshot to you. Then comes the very important question like what are the various roles in data science? The very first role is data analyst. Data analyst is a person that gather information from various sources. Sources could be third party. Sources could be your social media. Sources could be your your enterprise database. It could be any source, and it gather information and do a first level of analysis. Now, my dear friends, there's a difference between analysis and analytics. When I say analysis, I have my data in front of me. I'm just trying to relate that data with some pattern, with some trend, with some seasonality. That's it. Just converting that data into graphs and trying to form some story out of it. But when I talk about analytics, then I should have some algorithm should be running in the background. There must be some hidden pattern which is not quite visible, and there should be some mathematical computations works in the background to come to a conclusion. Now, this is the difference between analysis and analytics. So the purpose of data analyst is to just gather the data and give a first flavor of what kind of information can be easily drawn to proceed to the next level. Then comes the statistician. Statistician is a very, very old role. We have many institutes in India who give degree on statistics, but they have very, very crucial role here. Now, what happens, for example, if I'm a startup and I wanted to apply some new concept into the market, I won't be having deep pockets. I won't be having good money with me, good like mentorship with me, but I wanted to just test on some sample of data, because if I get successful on some sample of data, then it will help me to take some decisions. Now, this is where the statistician come into picture. The person actually apply the statistical test on some sample data and then help the data scientist to take decision of whether to proceed on the problem or not. So in some way, it is actually saving a lot of money of the industry. Now, how it is saving? Because it is working on the sample data. If the problem not gets solved, if the idea don't hit the market, then statistician can easily tell with the help of sample data. There are many statistical tests which are proven tests actually. They are not a new test. They are all the proven tests. There are a lot of research has gone in the background. So the result that we come from a statistical stat are all proven, and this actually help companies to take decisions. Should we launch a new product? Should we launch a new service? or should we go with this existing as a status quo? Then come the data scientist. Again, a very buzzword these days, and it's a very crucial role in any like data science field. So data scientist is a person who actually apply the machine learning and deep learning models. So whatever models I have shown in the previous slide, that's the mind map of all the machine learning models. So data scientist is a person who actually apply all these machine learning models on sample data and then explain the result to the management, because every model will give some output and the data scientist should know how to read this output. Is it actually serving the purpose or not? And finally, the management and the client, they don't know anything about how these complex machine learning models are working. They are ultimately concerned about what is the result. So to process the complex thing and then present in a very simple way is the role of data scientist. And it's a very tough role. It's a very challenging role. And a lot of research, a lot of learning is required to become a data scientist. Then come the data engineer. So the data engineer is a person who actually work on the big data or the large volume of data, and it basically apply the models which are suggested by the data scientist on a large volume. So data engineer person is very much expert in the Hadoop, in the Spark, or in the big data tools, and it actually apply the models which are suggested by the data scientist on a very large volume of the data. Now come data architect. So like in any normal architect, data architect is a person who actually set up the complete pipeline of the workflow, like from where I get the data, from where I process the data, where I store the results, how I display the result, how to make the system scalable. Today I have 1 million users. Next day I might be having 2 million users. Then how to scale up? If I wanted to experiment some new phases, what should be my repository? Where is my data lake? So these all answers are given by data architect. So data architect is basically set up a complete pipeline. Then data scientist, data engineers, statistician, and data analyst works on that. Then come the BI expert. According to me, BI expert is a magician. BI expert is a person who actually tells the story to the management, to the client. So whatever work data analyst, statistician, scientist, engineer, architect has done, ultimately it boils down to what result they get. Now the whole thing comes here: what result to show to the customer, and how to make our customer or the client understand the result. This is where the BA expert comes into picture. So they give a very precise and very up to the mark but relevant information to the client or to the management, and ultimately is a very crucial area where the things can get ruined, because data is a very dubious thing. It will show you a story which you want to see. So if you wanted to see some negative, the data will show you the negative story. And if you want to see some positive results out of it, data will show you the same story. So this is the role of the BA expert to actually discuss with the management and tell them that these are all the findings and how to present that finding in the form of dashboards, in the form of reports, in the form of any story, or maybe in the form of any video. So these are all the roles in data science. Now come the use cases. So you must have seen in your organization or maybe in your if I'm launching a new product, then how do I come to know who are my customers, who's my target segment, whom should I reach? There's a huge world out there. Whom should I knock? To whom I should I knock the door and say, okay, boss, can you buy my product? Now, with the help of this data science, we actually can predict which customer is going to buy our product with the help of historical data. Then come the estimated time to reach a destination. You all use Google Maps, you all use Ola and Uber. Whenever you book a cab, you get some estimated time that by this time the person will complete its visit and they'll come to you. Now, these all are estimated. When I say estimated, that means a likelihood is attached with it. It is not an exact time, it's an estimated time. These estimated time are calculated by a number of models which are running in the background, which take care of all the in conditions, for example, road traffic, the distance, the time, and the source and the destination. So these are all the like in points which actually it calculate, and they go beyond that, and then they calculate how to estimate the time. Then come the another use case called chances that a person will be prone to a particular disease due to lifestyle disorder. Now, this type of use cases are used in healthcare. You all like must have seen gadgets like Fitbit and your Apple Watch. So these all are actually capturing the data, like how much walks I have done, how much steps I have walked in a complete day, what are my body movement, which all places I visit, what kind of food I eat. Sometimes, like you might have heard that now the smart fridges is also in picture. Whatever we have put in the fridge, what kind of food I am eating. So this type of information goes to the healthcare companies, and then they predict the lifespan of a person depending on the food habits. The person is living alone, the person must be on the junk foods. So this kind of diseases which a person might be prone in a coming time. So this is where the healthcare comes into picture. Then the chances that a candidate selected by the company. These days, recruitment companies are also very smart. They are not only just watching the resumes, they are actually checking whether this person is actually comfortable, whether this person is actually apt to the culture of the company for which they are hiring. How many switches the person has done so far, what kind of skill set the person is showing, what is the reason why this person left the previous job, how many switches the person has done in 1 year, what is the like, how many people like him actually looking for a job, what is the current package, all these things comes here in the chances to by that the person will be selected by the company. And this is also where the analytics works. Then the identification of the object, you must have seen that like selfless drive cars are coming. So they're identifying object. Another car is on the road. There is a lamp. There is a road. There is a truck on the road. So such type of identifications. This is where this data science works. Then response to query. You must have heard about chatbots and voice bots. So they are responding to a query with the help of the NLP. Authentication and authorization by using facial recognition. These days, actually, face is speaking. Today, you don't have to punch your card, you don't have to put your thumb impression. Just show your face and you'll get authorized and authenticate for a particular transaction or for a particular access. Then estimate number of footfalls in a store and accordingly schedule the shifts. For example, if I'm running a store, how would I come to know that how many footfall is there? What are my repeated customers? Who are my high potential customers? Who are my high paying customers? And accordingly, I can shift my schedules with the help of data science. Then come like identify a particular transaction as a fraud happens in the banks. Like if I'm doing some transaction, so is it prone to a fraud? It is something alibi? Is it something outlier? Is it something susceptible to a different behavior? Such type of things are identified with millions and billions of data. Then come the predict life. A person will be defaulter on loan when a bank process the application. They get some data from CIBIL. They get some data from your social media as well. They see some data from your friends also. Like they need some guarantors and all. So they also have a historical data that who all are the defaulters. If I'm having a friend who is a defaulter, then the likelihood of me also defaulting actually high. These all things are actually applied in the processing of the loan application. Then predict success of a new product and movie and event by just looking for the social media data and what people are talking about the product. Do I need any improvement into my product? What kind of feedback people are giving? What kind of things my competitor is doing? These all are the use cases where data science plays a very, very crucial role. Now, the very, very important question is what companies are looking for in the candidates. Like you, me, when we go to a company, what kind of thing they are looking for. The very first and important thing is like they're looking for a very strong data science concepts. You should be having very strong data science concepts, starting from statistics to machine learning to deep learning or AI. So you should be very, very strong at data science and always focus on why this particular model is actually acceptable in this particular scenario. What kind of results this particular model is giving. This should be there in your concepts. You know how to apply, but you should also know why to apply a particular model. The companies are focusing more on the why part because they know that you already know how to implement this model. Then in hands-on knowledge on implementing and machine learning. So they are looking for people who actually work on R and Python and, and have applied some models on it. This is where the advisor groups comes to picture because they help you to work on some projects This is where you get mentors. This is where you get like a guardian who actually help you to do some baby steps in the starting, and then we give you a hand holding for a certain level. After that, you start working on your own projects. This is where this such type of like an environment is required. The person should be capable enough to understand the requirement properly, because if the requirement is not clear, then whatever things I'm going to make, it is going to be garbage. So they should looking for a person who should be very very good in the communication skill, and who should be interactive, who should interact with all kind of people. Reserved people do not have any like place in data science, because if I am reserved, then the whatever model I will make, it will never get integrated with any of the system, and that's a major problem. Now you build the model, but how deploy the model? You could deploy your local cloud environment, because if the model cannot be deployed, if the model cannot be interactive with other models, then what's the use of that model? So these days, most of the startups are looking for people who actually know data science, who can do hands-on on the data science, but at the same time who can deploy the models on the cloud. When I say cloud, it could be Google Cloud Platform, your Azure, and Amazon also, or any private cloud. And how to build the API. You build a model, you deploy it, but how the third party will use your cloud, how the third party will use your model. This is where the APIs come into picture. Then you should have expertise in R and Python. Both languages are equal, but in the industry, people are more inclined towards Python because it's a completely programming language. But every language has their limitations, so comes with R and Python. But my suggestion is, do not get restrict to one language. Always have a good understanding of both the language, because both languages have a very strong power. You should coordinate with the teams. As I said, you cannot work in the silos, so you should work with the teams, and don't hesitate in asking the questions. If you hesitate in asking the question, then there will be a big problem when you're working in industry, because a lot of new things are happening, and a lot of experiments are happening. If we do not clarify our doubts, then because of the assumptions, we may end up into building a very very long model, which may not be helping to our company, and it required a lot of cost. So it is always good to clarify your doubts, and then open to experiment and challenges. So these are the main areas that you should look for while applying for any data science like job. These things will be definitely looked by the recruiters, with the company owners, with the startups, and you should focus on these steps when you are learning data science. So this is all from my side, and I'm open for the questions. I'm looking for questions from you guys. So yeah, may I have the questions, please? Okay, so the first question is, what is exactly deep learning? So, sort of, as I like, so deep learning is a special branch of machine learning where we have, like, for example, like if I show you an object, and it's the first time that you have seen this object, you will ask me what is this object, and I'll say it's chair. Then you start building some feature in your mind that the chair has like a sitting arrangement, and it's on wheels, it has stand and all. So when your machines also think like how the brain works, this is where deep learning come into picture, where it's a very very complex calculations happens. Now when the very very complex calculations happens, then a lot of message get communicated from one layer to another layer. A lot of information gets shared, and this is what is covered in the deep learning area. And the difference between machine learning and deep learning is, machine learning is still a very high level as compared to deep learning. In the case of machine learning, you should already know what all features are required to basically go up to a conclusion. But in the case of deep learning, you just show the image and you say that, okay, compare this image with the existing person. You won't tell your machine that it's an eyes, it's a nose, it's an ear. Machine automatically build that insight. Machine automatically build that feature for you. And this is what happens in the deep learning. However, in the machine learning, you have to explicitly give the features. You should be expert in your domain when you're working in the machine learning. And if you're not expert in the domain, with the help of deep learning, you can do wonders. You can build the chatbots, you can build the sentence corrections, you can build the image recognition. So these all are the applications of machine learning, sorry, deep learning. So the next question is for Akash. You are an MCA student in data science. Is data science for me? Yes, data science is for everybody, I would say, because there is no such field exists where we do not have a data science. No particular domain exists these days where we do not have a data science. You are an MCA, you are a master of computer application, so you know all the like an full stack development. For example, you know the Node.js, you know the Python programming and all. So you can give a shape to a model. A model is developed now. Convert that model into a product. I won't be deploying a model. Just it should make a shape of a product. It should make a shape of an API. It should make a shape of a web service. So MCS people actually have a very good role because you already have computer science knowledge with you. Now just add a data science in top of it, and you are a complete package for anybody to hire. For example, if I'm going to hire a person, if I'm getting an MCA guy who know how the programming works and has a very good concepts in data science, I will love to work with that person. Now, Viresh Murata is saying, what is the future scope of data science? Future, I'm talking about present. Present has a very good scope. Future is already having a very bright scope of data science. A lot of requirement is there in data science, and in today world, the demand and supply is completely mismatched. Demand is very high and supply is very low. And good data science people, supply is very low. On an average, one person having 3 to 5 jobs if a person is very expert in data science area. And future data science will be your de facto. It will be required. It will club with the IoT. It will club with the blockchain. It will club with many other new fields. But ultimately, this data science is required. So there's a very big scope of data science. And if you're planning to do any course into it, go for it. So we are currently in second year in MTech mechanical, and so you are from mechanical background. A mechanical background has just started the data science field. For example, industries where they have like in big machines. Now, with the help of just images, they can count the number of pieces. For example, if I'm having a conveyor belt and I'm building a piston, right, in my company. So the piston is going from a conveyor belt. With the help of sensors, with the help of images, I can easily detect the like malfunction in the machine. I can easily detect the rejected path, rejected products with the help of images. So your MTech has a very good role for data science, provided you actually apply some domain knowledge into it. Because if you just go into the MTech field and say that I'm a data scientist and hire me, no, they won't hire you. You say I'm a data scientist and I can solve a problem for you, and this is a prototype that I have built. If you solve somebody problem, then only the other person will listen you. Today I'm giving a session, I'm solving your problem. That's why you are listening me. So always remember that if person is listening you are solving their problem. You cannot say that I'm a data scientist, hire me. They say that there are a lot of data scientists are going in the market. Why should I hire you? Okay. And Shweta is asking like which is better, R and Python for data science. I personally prefer Python, but there is no like strict rule for R and Python, provided you are what kind of work you are doing. If you're working on the statistics part, I would definitely prefer R in statistics, which is very strong in statistics. But if I'm talking about a deep learning area where I wanted to work on TensorFlow, I wanted to work on Keras, I wanted to write deep learning models, then I will definitely go with Python because it's a completely programming language. It gives a proper shape to my product. Now, Sudeep Bansal is asking what special mathematical skills are required in making models. So, I would say, Sudeep, mathematical skills are very basic, but you should have a logic behind. Simple multiplication, subtraction, division occurs. Matrices you must have read. Matrices is actually a area where a lot of models are working. Then your differentiation and integration, some level of understanding of this thing actually help you, but this comes with the experience. Probability, for example, this comes with the experience. So there is no strict mathematical skill required. If you are from an arts graduate, then also you can apply data science, because data science has provided so many tools where you should not be going in depth on like how this model is working. Maybe just with the help of their wrapper class which they have there written, maybe with the help of the interface that they have provided, you can still do your job. So mathematical skills are required, but if you don't have a mathematical skill, it can be developed, because a lot of derivations are not required here. Most of the models are prepared. You just need to apply those models and understand how to fine tune those models. So there is a scope of people who are not having mathematical background as well. More questions, please. So guys, first of all, tell me, are you do you see that this session is helpful for you? Are you like, am I able to answer your queries? Great, because this actually give me the motivation that yes, I'm able to contribute something to you guys. So I'm open to ask you. You can ask questions to me, and I'm here to answer your queries. Any more questions, or are we done? Okay. So shall I close the session now? And I wish you all the best. And if you are thinking of learning data science, then no, don't make delay. Give it a start, and start with some small steps, and automatically you will get involved in the data science field, and it is very much required. Thanks to all. Thank you very much. Take care. Bye bye. God bless.